this last section of chapter 6, it's going to kind of introduce us to another use of this fraction format called a ratio. So far, in everything that we've done in chapter 6, our fraction, for instance, 1/3, has represented a part of a whole. So if I had a candy bar and I split it into 3 pieces, that 1/3 would represent 1 out of 3 pieces. When I'm dealing with these ratios and proportions, they're actually going to mean something different. So instead of that part to whole, it's going to be our part to part. So I'm going to be comparing these. And a lot of times we'll see it written in this A to B form. Part of something to another part of something. So we won't be using that whole there. Now our proportion is where we're going to be setting these two ratios equal to each other and trying to solve for something. So first let's just practice with the ratios themselves, and then we'll practice finding like a missing part to them with the proportions. Let's see. So first we've got in this ratio format of 20:1. There are a couple different ways we could think about solving these. I'm going to do it not with their proportion right now. It's going to be a similar problem on the back side of the page. So if you get the same answer in a different way, it's still completely fine. There's nothing wrong with it. So basically, these ratios are going to be reduced down, just like we saw our fractions. This is simplest form. So this is a fact that is given a lot on college websites. You might have remembered when you were looking around at colleges what the ratio of students to faculty, or sometimes the other way, faculty to students. So for every 20 students, there's 1 faculty member is what this means. But in a college, there's not just 1 faculty and 20 students. There's going to be more than that. So let's say in maybe the school that we're in, the college we're in, maybe not the whole university, or just maybe our freshman class or something, that we actually have 200 students. So we want to know how many faculty members that really is. To get 20 to turn into 200, I multiplied by 10. So if I multiply this by 10, 1 times 10 gives me the answer of 10. So just like we saw with fractions, what you do to one side, you want to do to the other. We're going to keep them the same proportions here. We can't be lopsided at all. Now for the second one, it's kind of a grammar thing and a little bit of practice of what we did in the last section. We've got this as a ratio, but we really want it written in A or B form where A and B are whole numbers. Right now it's written where A and B are integers. We don't really, not integers, they're A and B are rational numbers. We don't want them to be rational numbers, we want them to be whole numbers. Let me just rewrite this so we can see it out. This really is the same thing as 1/5 over 3/7. It's a fraction divided by a fraction. So we learned in the last section that when you divide fractions, you keep, change, flip. So all the rules that we learned before still hold true even when we're dealing with these in our ratio format instead of our fraction format. So multiplying the numerators gives me 7, multiplying the denominators gives me 15. So now it is in that A over B form where A and B are both whole numbers, because 7's a whole number and 15 is a whole number.